Question number 2 is on the topic of electricity. Body analysis scales use the electrical resistance of a person's leg to estimate the percentage of water in a person's body. Figure 3 shows body analysis scales. The person's legs contain solid tissue and water. A student used resistors to model the solid tissue and water. The student connected a 20 ohm resistor in parallel with a resistor capital R. The figure 4 shows the circuit diagram. So remember, both these resistors, the 20 ohm resistor and the resistor R, are connected parallelly. If they were connected in series, it should look like this. Right, so you've got the 20 ohm resistor and the resistor R in series. To determine the total resistance of both resistors, a voltmeter must be connected into the circuit. Complete figure 4 to show where the voltmeter should be connected. Now, in order to measure the voltage across both resistors, right, not just a single resistor, you need to connect it across both of them. One mark to get the symbol correct, which is V in a circle, and one mark, actually it's just one mark for this. So you need to make sure that it is connected correctly with the correct symbol. The student calculated the total resistance of the two resistors. The student's answer was 26 ohms. Explained by the student's answer cannot be correct. Now, one of the key things that you have to remember about resistors when connecting in series and parallel. Let's say if this resistor R is also 20 ohms. Let me use a different color. So if this is a 20 ohm resistor as well, total resistance will simply be, or if I say capital RT for total, equals R1 plus R2 is a sum of all resistance. So that makes it 40 ohms. Now, what if it was connected parallelly? How do you calculate the total resistance? The equation is 1 over the total resistance is equal to 1 over R1 plus 1 over R2. Now, you need to be aware of the equation. You're not meant to carry out any calculations for GCSE, but you need to understand the implication of this. So let me do the calculation. That way you can definitely see what happens to the value. So 1 over R1 is equal to 1 over 20 plus 1 over 20. Now 1 divided by 20 is 0.05. So if you add that, 1 over RT equals 0.10. Rearranging, RT is equal to 1 divided by 0.1, and that is 10 ohms. So you can see what's happening to the total resistance. The total resistance drops, right? And one of the key things that you need to remember when you're answering this question is that when you connect resistors in parallelly, the total resistance of the combination is less than the value of any of the resistors. So your answer for this question, explain why the student cannot be correct, because 26 ohms is more than 20 ohms, which is one of the resistors. So the marking scheme answer the total resistance must be less than 20 ohms, because the total resistance of the resistors in parallel is, you say always, less than the resistance of the smallest resistor. Use the physics equation sheet to answer questions 2.3 and 2.4. Write down the equation that links current, resistance and potential difference, which will be V equals IR. Now you can write the symbol equation or the word equation, it doesn't really matter which one you actually write. So here I've written down the symbol equation. V for potential difference, I is current and R is resistance. When the total resistance of the resistors was 7.5 ohms, the current in the circuit was 400 mA. Now again, in the physics paper, I've seen continuously that they're actually asking for this mA is milliamps. Milli is 1,000th, which is the same as 10 to the power minus 3. So 480 milliamps is equal to 480 times 10 to the power minus 3 amps, which is 0.480 amps. Using the equation V equals IR, 0.48 times 7.5 will give you 3.6 volts. 3.6. 1 mark for the conversion. If you don't do the conversion, then you just get 2 marks for the correct substitution and the correct answer here. The student investigated how the resistance of R affected the total resistance of the circuit. Table 1 shows the results. So as you can see from the table, resistance of R in ohms and total resistance of the circuit in ohms. So it's increasing by 5 ohms and the total resistance is also increasing. Now you'll see that the total resistance is always less than any of these values because they're connected parallelly. Some of the results are plotted in figure 5. Complete figure 5, you should label both axes, plot the 2 remaining values from table 1, draw the line of best fit. Each of these gets you a mark for the 3 marks. So label both axes. How do we label both axes? So the x-axis is going from increments of 5. So this should be the resistance of R in ohms, right? So you need to remember you're literally using, if I bring the copy of the table here, so we are literally using the headings which is in the graph, in the table that's been provided. So the y-axis is going to be the total resistance of the circuit in ohms. Now the value for 15 and 20 are missing, so 15 is 8.6, so 15, that's 8, this is 9, so 3 boxes above, right? So remember this is 1, so that's 5 boxes 1 divided by 5 is 0.2 ohms. So 8.6 is 3 boxes above the 8. 15 was that, and 20 ohm is 10. So when it is 10, that's like this. Now they are asking you to draw the line of best fit. It has to start at 0. Now it cannot be a straight line. It has to be a curve like that. I nearly managed it. You need to try and get the curve as much as possible in the lines. You don't want to draw a straight line here. So if you draw a straight line, it would actually go through this and will point somewhere, end up somewhere here, which is incorrect. What resistance of R would give a total resistance of 4.4 ohms? Now 4.4 ohms, what resistance of R? Total resistance 4.4. So 4.4 is here. So that's 5. 4.4 is where there. So let's see what the marking scheme says. Reading, right? So the marking scheme basically says reading from the graph consistent with their line of best fit. So according to my line, it's 5 ohms. Right? So five ohms. Again, yours might be slightly bit different depending on the line that you draw. The body's analysis scales initially show a reading of 0 kilogram. When the student steps onto the scale, the reading is 64.8 kilogram. The student steps off the scale and then immediately steps back on again. The scales now show a reading of 64.1, difference of 0.7 kilogram. Complete the sentence. The difference between the two values given by the scale is due to, is what we call a random error. Now, a random error is what you get when you are taking measurements, right? And it gives you different numbers. Now, the other type of error is a systematic error. Systematic error is, let's say, initially, it's showing a reading of 0.1 kilogram. So every single time you weigh, is always going to add that 0.1 kilogram. That's a systematic error, right? The height of the student is programmed into the scales. The scales place the student into a category A, B, or C based on height and mass. Figure 6 shows how the scales use the category and the total resistance of the legs to determine the body water percentage. So you've got 3 lines, all of them are starting around 80%, and it's coming towards 35%, and the resistance is slightly different. They're all starting near this 300 value. So 300, 325, about 350. The total resistance of the student's leg is 600 kilo ohms. So the total resistance is here, where it's 600. So if I draw a dotted line for 600, a healthy body water percentage is between 45% and 65%. The different measurements of the mass of the student mean that the student could be either category A or category B. Evaluate if the student has a healthy body water percentage. So now we are starting off with 2 mass values, which is 64.8 and 64.1. Now, which mass is actually correct? This is why we've got these two values here. So 45% and 65%. Now, when it's 600 kilo ohms, that is 60%, right? The student is 60%. That means they are healthy. And because it falls between 45 and 65, so if you are looking at this line, the student is healthy. Now, if we are looking at category A or B, so if I am looking at B, then that is above the 65%. 65% is somewhere here, right? Slightly lower than that. So this is nearly 68%. So if I'm looking at line B, then the student is unhealthy. So according to the marking scheme, the answer is, so in category A, the body water percentage is 61%. I was off by a little, 1%. In category B, the water percentage is 68%. If in category A, they have a healthy body water percentage, and if in category B, they have an unhealthy body water percentage. That brings us to the end of question number 2, and I will see you in question number 3.